Hi everyone, welcome to this video of chapter 14, Firms in Competitive Markets. This is a book of Gregor Mankiw. We're going to develop exercises from 7 to 12. Remember, this is the book Principles of Economics 7th edition. So the first question says, a firm in a competitive market receives $500 in total revenue and has marginal revenue of $10. What is the average revenue and how many units were sold? So first we have this information. So we have the total revenue, which is 500. Remember, total revenue is the price times the quantities you sell. Then the marginal revenue. Remember, marginal revenue is basically which is going to be the revenue of selling an additional unit. Then we need to discover about the unit sold. Remember that in a competitive market, the characteristic is that the price is exactly the same as the average revenue and exactly as the marginal revenue at that point. So remember that the marginal revenue and the average revenue is exactly the same in the competitive market, because any unit that you sell in the market, this is going to represent exactly the same additional revenue. And when you divide that, the total revenue over the quantity, this is going to be naturally the average revenue. Remember, definition of the average revenue is equal to total revenue over quantity. Then we can put this one from the right to the left. Due to this in the denominator, it can go here to multiply this one, and then this one can go down here. So then we will have like the total revenue is going to be 500 over the quantity is going to be 500 over 10. Then the quantities sold were 50. Then, what is its profit? Sorry, this one I'm going to read the first part. So, a profit maximizing firm in a competitive market is currently producing 100 units of output. It has average revenue of $10, average total cost of $8, and fixed cost of 200. So what is its profit? Remember, first I summarize this one. The quantity sold, quantity is 100. The average revenue is going to be 10, and the average total cost is going to be 8. Then the fixed cost is going to be $8. Then the benefits, remember, is going to be the input, all the money you receive minus all the money you spend, all the output. This difference, if it's positive, it's going to be the positive profits. If not, it's going to be definitely losses. Then I'm going to make kind of a trick in order to use the information that the problem provides to us. And the total revenue, you can think about, you know that the average revenue is exactly the same as total revenue over Q. If you multiply by Q, you will find again total revenue. So average revenue is going to be total revenue over Q. You cancel these out, you will find this one. It's basically the same in the total cost, because when you have the average total cost, it represents by total cost over Q times Q is going to be total cost. So basically, I just change that. So average revenue we already have, quantities as well, and the average total cost as well. So once we have this one, this multiplication 10 times 100 is going to be 1000, and 8 times 100 is going to be 8000. Then the profits of this firm is going to be 200. Then what is its marginal cost? Remember, the definition of the marginal cost is basically how much is going to increase the total cost once you produce an additional unit. So for this reason is represented with the Greek letter of delta. Basically, the idea is like in the condition of a competitive market is like the price is going to be exactly at the as the marginal revenue and exactly at the marginal cost. And due to we already have here at certain point we have this one the marginal revenue is exactly the same as the average revenue, then we will find that the marginal cost is going to be 10. Then what is average variable cost then? Remember that the total cost is divided by two parts. One, which is the part that varies with the quantities, so this is going to be the variable cost, and the other part which is fixed because it doesn't depend on the quantity produced. Then you have variable cost plus fixed cost. Then you can divide all that quantities. You are not doing anything special. You are not changing because this equation, which is a balance, is still balanced. You are dividing in both sides by quantities. Then you'll arrive to the average total cost is exactly the same as the average variable cost plus the average fixed cost. Then you just isolate the average variable cost is equal to average total cost minus average fixed cost. Then the average variable cost is going to be 8 because you already have this one. The average total cost is going to be 8, and the average variable cost by definition is the fixed cost, which is to be 200 over 100, which is the production. Then your average variable cost at that particular point is going to be equal to 6. Then, is the efficiency scale of the firm more than, less than, or exactly 100 units? First, which is the definition of efficiency scale? The efficiency scale, it comes from the idea that you are minimizing the average total cost of your production. So remember that this is U-shaped. So once this is U-shaped, when you're working as a efficiency scale, you are thinking about the minimum. So you are thinking about the minimum point of this average total cost. So we're going to try to represent that. So here we have the quantities, the average revenue, and the average total cost and the fixed cost. Then the idea is like the efficiency scale is exactly when the marginal cost is equal to the average total cost. So maybe, I'm sorry here, maybe not variable cost, but better total cost. Due to the marginal cost is smaller than the average variable cost is decreasing, and the marginal cost is higher when the average total cost is smaller and when it's increasing. So this is higher when it's increasing part. So for this reason, this is exactly the minimum point of the average total cost. Then the idea is like you have here the average total cost. Okay, so this average total cost, this is not variable, this is total cost. This is going to be this one, which is going to be 10, right? This is 10. This is the price that they sell. Okay, and the quantities is going to be 100. And this one, naturally, at that point, the average total cost is 8. So then what we're trying to find here is like if you multiply the average total cost 8 times the quantities 100, you will have here the total cost. And the total revenue is going to be 100 times 10, which is going to be 1000. So this difference, this rectangle here, this is going to be the benefit. So and the efficiency scale is going to be this specific point when the marginal cost exactly the average total cost here. Okay, then this efficiency scale. Then the next point says the market for fertilizer is perfectly competitive. Firms in the market are producing output but are currently incurring economic losses. How does the price of fertilizer compare to the average total cost, the average variable cost, and the marginal cost of producing fertilizer? Then we have here, remember that we are starting, or we start from the point of the economic losses. But remember, if a firm still stays in the market, it's because this firm is at least covering the completely the fixed cost, and actually they are covering in some way the variable cost. So then we have here the average variable cost. Here we have the average total cost. Remember, this difference between those two is the average fixed cost. Then this one, imagine that this is the price. This is the price, exactly, this one. So at that time, you are sure you are like losing this part because you cannot cover that. So this is going to be actually it's going to be exactly this dotted line a little bit to the left. This is going to be the quantity offer in the market, and actually this one is going to be the real cost, and this one is going to be the real income, or the real revenue, and this difference is going to be the losses. But you still stay in the market, because remember, if you leave the market you need to pay the fixed cost. So then it's better to stay in the market and pay a little bit part of that fixed cost, the fixed cost totally, and part of the variable cost. Then at that time, so we have here with the price exactly the marginal cost and the margin revenue. Then this is going to be the quantity. So this is going to be unto here. I'm so sorry. Unto here is going to be the income, right? Total revenue is going to be this one. Actually, is going to be the other side. This one is going to be the cost. This is going to be total revenue, and this one they're going to be the basically the revenue. Okay, it's like upside down. Okay, then this one is going to be considered as the losses, because this level of price of higher, this is basically when there are no profits. So this one you will find like losses here. Then draw two graphs side by side illustrating the present situation for a typical firm and for the market. So the situation is, as we noticed before, is going to be around here. As I said before, this is going to be better dotted line a little bit to the left, and then this one, from this one, this is going to be the supply curve. This is the quantity, which is lowercase, which represents the situation of a firm. And then when we represent that the market, we will see how this one is going to be kind of the same, just with the difference that this Q uppercase is going to be the sum of all of these Q of each firms, and in general there's going to be a negative benefits in the market. Then, assuming there is no change in either demand or the firm's cost curves, explain what will happen in the long run to the price of fertilizer, marginal cost, average total cost, the quantity supplied by each firm, and the total quantity supplied to the market. So remember, when we have here the graph which represents the situation of the market, when in the axis we're not going to put the cost and the quantities, but we're going to represent price in the y-axis and quantities in the x-axis. So we have here, as usual, we have the upward slope of supply, we have here the downward slope of demand. So remember what happened in the short run that we figured out in previous one. The idea is like the firms in general, they face losses. So basically, some firms naturally they leave the market. Just the more competitive firms, they can stay in the market. They can face the market because due to the shapes, the cost that they have, they can still manage that. So for this reason, the supply will shift to the left. So immediately, according to our previous knowledge, when we have this uh, change of the supply, automatically the prices will increase and the quantities will decrease. So the question says about the about this one. So remember the marginal cost. So here we have, okay, and now we have this new situation where the price is going to be exactly at that point when there are no losses, there are no benefits. The equilibrium in the long run, all the firms have a zero benefits. Then the marginal cost naturally will increase as well. Okay, so this one, the marginal cost will increase. The average total cost, remember the previous situation, what we have was like around here, right? So it was to the a little bit to the left. So definitely the average total cost will increase, and the quantity supplied by each firm at the end, what we have here, they are going to increase a little bit, but as a total, in the total economy, the quantity decrease, but by each firm will increase, and the total quantity supply in the market will decrease. Then is basically what will happen. Okay, and this one is going to be the supply of the market. And please avoid this average variable cost, because remember, in the long run, all the firms face just variable cost, not fixed cost. So average variable cost is exactly the same as the average total cost. Then, the market for apple pies in the city of Ectenia is competitive and has the following demand schedule. So here we have the price from 1 to 13 and the quantity demanded from 1,200 pies over 0 pies. This one, by the law of demand, when the price increases, the quantity demand decreases naturally. Then the first question says, compute each producer's total cost in average total cost for 1 to 6 pies. So here we have, this is the information provided by the exercises, the quantities from 1 to 6, and the marginal cost from 2 to, and this one, okay, from the same 1 to 6. Then, according to that, we can infer first that this one, the total cost of this one is going to be 2. Remember, because at that time the marginal cost changes from this one from 0 to 2. Okay, then at that time we have this one is going to be 2. Okay, assuming that the quantity is 0, the total cost is 0, so we're not taking at that time basically kind of a fixed cost in some way. So here we have 2. Okay, then okay, this one we have 2. Then this is going to be, remember, this one is the change of the total cost. So this one, if you put 6, 6 minus 2 is going to be 4. Okay, then this one is going to be 12 minus 6 is going to be 6. 20 over minus 12 is going to be 8. Then 30 minus 20 is going to be 10. And 42 minus 30 is going to be 12. Then the average cost is going to be basically this one divided by the quantity is going to be 2 over 1, 6 over 2, 12 over 3, 20 over 4, 30 over 5, and 42 over 6. Then the price of a pie is now 11. How many pies are sold? How many pies does each producer make? And how many producers are there? How much profit does each producer earn? First, we have the idea that 200 pies are sold. Why? Because when the pie is 11, you immediately in the market they will demand 200. Okay, then 200 pies are sold. So this is the first question. How many pies does each producer make? So then, when you have that, the price is going to be exactly as the marginal cost. then is going to be this one, the price is going to be this one, 11 is in between 5 and 6. So let's take this one. So then you have the quantities, they're going to be 5. Then the producers, they're going to be 200 over 5. Then the number of producers is going to be 40, and each one produces 5. Then the profits are defined by the total revenue minus total cost. Then total revenue is going to be 5, okay, times the price, 11, minus total cost. Total cost, 30. Then it's going to be 55 minus 30 is going to be 50. Maybe we can think about take these 6. We have these 6. It's going to be the quantity is going to be 6, okay, times the price is going to be 11. Then we will have 66 minus 42. This is going to be 14. Then you maximize more with this, the 5. Okay, for this reason you choose 5. Okay, great. Then in the situation described in the part B, a long run equilibrium, is the situation a long run equilibrium? Why or why not? Remember, when you have positive benefits, this is not long run equilibrium, because when the market represents positive benefit, this is an incentive for other firms to go into the market, so they will go until the benefits will be automatically zero. Then at that point, definitely not. Then suppose that in the long run there is a free entry and exit. How much profit does each producer earn in the long run equilibrium? Zero. Remember, zero is going to be that. What is the market price and number of each producer makes? Then the idea is like you will find where the benefits are going to be exactly zero. So think about this one, when the price is exactly equal to the marginal cost. So if the price is exactly of 2, then you will be here. When the price is 2, this is going to be the quantity demanded, 100, 1,100, and then due to this one, due to the price exactly 2, and this is going to be exactly of the marginal cost, the quantity of each firm produced is going to be Q equal to 1. And then the benefits is going to be total revenue is going to be quantities 1 times the price, which is going to be 2. This is going to be your total revenue 2 minus the total cost, which is going to be 2. Then this one is going to be the quantity. Then suppose that the US textile industry is competitive and there is no international trade in textiles. In long run equilibrium, the price per unit of cloth is $30. Describe the equilibrium using graphs for the entire market and for individual producer. The idea is like when we have here, this is the point where we have the price equal to marginal cost equal to marginal revenue equal to 30. Then this is going to be the quantity produced by each only producer, and when the benefits exactly 0 because we are in the long run equilibrium, then for the entire market it's going to be exactly the same, just with the difference that this quantity is going to be uppercase, which is going to be the sum of all firms in the industry. And just the last part, this violet line, this is going to be the supply curve for this market. Now, now suppose that textile producers in other countries are willing to sell large quantities of cloth in the United States for only $25 per unit. So automatically, when this kind of price is in the market, you need to offer this this good to the same price. So then you will face immediately benefits of negative benefits basically. So the idea is like this one This is going to be actually not the total revenue, but sorry, again, it's going to be total cost. This is going to be the total revenue. Then you have here the losses. Okay, this is going to happen actually. It's going to be losses for on the industry due to this stuff. So then the idea at that time, because if you are thinking of a long run equilibrium, just the firms that they can change, they are competitive to the outside market, they're going to be at that point. Just this one that they are not competitive, they will leave the market. Then, assuming that US textile producers have large fixed costs, what is the short run effect of these imports of the quantity produced by an individual EU producers? What is the short run effect on profits? Illustrate your answer with a graph. So as we represent before, is like this one is the condition with benefit zero, but immediately when we have this one, they still produce. Okay, this P prime is going to be the change due to the competitors, the foreign competitors that they can offer to a lower price, so they will still remain, or they will still stay in the market due to they can provide, due to they can at least cover a part of the fixed cost in some way, in totally part of the variable cost. Then, what is the long run effect of the number of US firms in the industry? They will decrease, because naturally just the firms that they can be competitive as the foreign competitors, foreign takeovers, you can stay in the market. Other firms that they are not competitive, and in the long run where all the costs they are variable, you need to leave the market. So this one maybe you can omit the variable cost, and we are just thinking about the total cost. Then they will leave the market. Okay, they will leave until actually this one occurs. These kind of shapes of the firms, they can be competitive of the foreigners. Then the other and last point says an industry currently has 100 firms, each of which has fixed costs of 16 and average variable costs as follows. A. Compute a firm's marginal cost and average total cost for each quantity from 1 to 6. So we already have this information, the average variable cost. Then the variable cost is going to be basically the multiplication of Q times ABC. The average variable cost is going to be 1 times 1, 2 times 2, so on and so forth until here. The total, the marginal cost is going to be the change of the variable cost. This one is going to be 1, assuming that's 0. At that time they just have 16, which is the fixed cost, but the change is going to be the 1 from 16 to 17, the variable cost. Then it would 1 basically. So this one, so again, the total cost for the 0 is going to be 16. For the first unit, it's going to be 17, so it's going to be 1. Then the margin cost is going to be 3. This one 9 minus 4, 16 minus 9, 25 minus 16, and 36 minus 25. Then the total cost is going to be basically this one plus 16. 14 plus 16, 9 plus 16. This one maybe is not totally right. Let me see here. Be 16. This one is going to be actually 25, right? This is going to be 25. I'm sorry. This one is going to be 32. This is going to be 44, 41, and this one is going to be 52. And the average total cost is going to be this one divided by 1. This one divided this one, which I guess is wrong, because it's going to be, as I said before, this is going to be 25 over 3. This is going to be this one 8.33. I'm so sorry. This one is going to be 8. 32 over 4. This one is going to be 8.2, and this one is not going to be 6. I'm so sorry, I did these two wrong. It's going to be 52 divided 6 is going to be 8. Maybe I'm going to correct here these two that I did wrong. This one, as I said before, this is going to be 8, 3, 3. This one is wrong again. It's going to be this one is going to be 25, and this one again is wrong. This is going to be this one over 6. It's going to be 8. Okay, that's better. Okay, great. Then so okay, we already know that this was not okay. Okay, then we have this one, which is corrected partially because still this one is wrong and this one is wrong. Okay. Okay. Then the equilibrium price is currently $10. How much does each firm produce, and what is the total quantity supplied in the market? Then the price is $10. Then immediately you need to make this equal to this one. Okay. Then we have this one. So the price is going to be 5. The quantity is going to be 5. Then what is the total quantity supply? Well, at that time it's going to be 5 by each firm times 10, 10 firms. Then it's going to be this is going to be the value. And then the other question says, in the long run, firms can enter and exit the market, and all entrants have the same cost as above. As this market makes the transition to its long-run equilibrium, will the price rise or fall? Will the quantity demanded rise or fall? Will the quantity supplied by each firm rise or fall? Explain your answer. So the idea, like the benefits, is total revenue minus total cost. So the total revenue is price times Q minus total cost. We already know that the price is 10 and the quantity is 5. Then it's going to be 41. Maybe you can think about a price. Remember that the price is exactly 10, so maybe we can make this one. But when we use this one, this is going to be this 6 times 6 times 10 is going to be 60 minus associated 52 is going to be 8, which is lower profit than this one. Okay, so for this reason we use this part. So then this is the benefits of 9. So the idea is like the price will go down. Why? Because there is a positive benefit, so more companies will enter into the market until the benefits will go to 0. Then quantities will rise because more companies they are in the market, but definitely by each firm they will decrease. Okay, because the price will be lower and each firm produce less. Okay, and then the quantity for each firm will decrease. Then the graph the long run supply curve for this market, which is specific numbers of the x's. So this one is already okay. This is the value is okay. Then we have this one, the average total cost, which is basically it starts this one. Suppose that this is 17. Okay, this is the minimum one. Okay, which is 8, and then it starts to increase. Then let me see here. This one is going to be 4. Okay, this one, which is the minimum. Okay, of this one, and this one is going to be 7 because it's this one, the marginal cost. Okay, so this, I'm sorry, this one better here, and I'm going to represent that the average total cost, because remember in the long run we don't have the variable cost, and this part, this is going to be the long run supply when it goes from the average total cost when the minimum. This one is going to be supply in the long run. Okay, I hope that is all for today. As I said, every single video is like my point of view. Maybe it's not something like 100% that this is the real, like the total true 100%, but it's my point of view. Anything, any comment you can say on the video, please go to the comments. And that's it. We can learn all together. So please have a great day. Bye bye. See you in the next video.